And off we go. All right. So guys, again, this triangle that you have in front of you is all that you need today. Just single-sided. There's no back. This is it. And guys, it's actually even more condensed than that. But here's what you're going to want to do. Across the very tippy top of this page, you may want to write down classification of matter. Get it high so that you still have additional space. And then guys, the date today is the 23rd. First day of fall. Yeah. Last night was that magical day when night and day are the same length. The autumnal equinox. Autumn equal, huh? Yeah? Oh, see, you guys are learning and you're not even supposed to be learning yet. Which one? Autumnal? I know, it's a beautiful term. Hey, so guys, let me explain to you what we're doing today. So if you think back to the test that you just took, you don't find it surprising to find out that that whole first unit was super foundational, right? How do you deal with numbers? How do you collect data? How do you keep from killing yourself in lab? How do you light a Bunsen burner? Guys, everything we did in the first unit was just setting the stage for everything we're going to do for the rest of the year. Guys, this unit is transitional. Think about it this way. Ready? You guys all either are related to or know somebody that served an LDS mission, right? All right. We share that in common, not surprisingly. So guys, before they send these poor 18-year-olds off into foreign countries to try to figure out how to survive on their own and share the gospel, where do they go first? The MTC. And guys, two very important things happen in the MTC. Some of them, oh, never mind. So what are the two things that happen in the, what do you learn in the MTC? A language and foundational truth, right? And guys, that's what they do before they send these guys and girls out, is first of all, they give you the important nuggets, the stuff you really got to know, and then they teach you how to talk about it in a foreign language. Guys, this today is kind of like going to the MTC. Guys, today what you're going to learn are some, they're literally foundational nuggets. We're going to do this together. Guys, grab something you can write with and underline these foundational nuggets. I'm definitely not going to say this is gospel, but guys, these are foundational ideas. For the rest of the year, you are going to need to be able to speak intelligently about elements, compound solutions, and heterogeneous mixtures. So your goal today is to understand this stuff. But part of this is learning a new language, because you've got to understand what homo and heterogeneous means. What are substances? Things like this. So guys, today's language lessons. So, to be ready for this, here's what you need to do. See this line right here? Get rid of it. Guys, cross that line off of your notes. You're going to find out at the end of the day today that line is unnecessary. And you'll see why. But for now, just get rid of it. And actually, we're going to do this, Cam. You can write this, and then it all makes sense. These are the same. And again, you'll see why. You guys okay? Okay, so guys, what I want to do is I want to help you understand the structure of this triangle, and then we're going to define a couple terms, and then we're going to get going and light some stuff on fire. So it goes like this. Guys, if you allow your eye to step outside of the triangle and look at the words that sort of provide the order, guys, you'll notice that this triangle goes from specific to general. So down here at the bottom are the really specific ways to talk about stuff, and then it gets more general as you go up. So that if you go down, these break down into subcategories. Do you see the subcategory? Bump, a bump, a bump, a bump. They're all subcategories of each other. And then, guys, from left to right, it goes from ordered to disordered. So we're going to work our way like this. We're going to go left to right, but we're going to go left to right to up to right to up to down to out. You get that? So we're going to go here, then up, then down, then up, then over and up and out. And guys, you should have time to get a good chunk of your homework done today, even though it's early out. You guys good to go? Okay. Now, guys, in order to do this, and this isn't me being weird. Guys, you're going to see this screen is going to be all full up with stuff by the end of the day. I would encourage you to write down stuff where I put it on the screen because I know it'll fit. So guys, up here in the upper left-hand corner, scratch down these two terms. I ask you because you're David, is that okay? Yeah. Is that? Hey, even I can read that. That's pretty good. So guys, these are two important terms that you need to know. This is going to become the lens through which we understand elements, compounds, solutions, and heterogeneous mixtures. And momentarily, I'm going to give you the opportunity to think about these things through this lens. So guys, first of all, chemical properties. Chemical properties are properties of substances that you can only observe by creating something new. I'll show you in a minute. And then guys, physical properties are properties of substances. We okay so far? You guys hands cramped up yet? You guys are good? We okay? All right, so guys, we're going to start down here in the very bottom left and work our way across. So guys, let's start with the term elements. And I'm going to define it for you first, and then we're going to talk. So guys, an element, you may know this, is actually a substance that only contains one type of different, ready, types of elements are there? Oh, I love your looking. Where are you looking? All right, so everybody's glancing either up or down at your table because you've got the periodic table of elements. And guys, the question is, how many different kinds of elements are there? 118, 100 and guys, actually the answer is we don't know. But something interesting is happening, and I'd love for you to understand this. So guys, look at element 92. Find element 92 on your periodic table. What is it? Yeah, uranium. And guys, uranium is actually a very, very special element. Well, here, I can show you some. So guys, this is actually what uranium looks like when we dig it out of the ground. This is actually from the uranium mine that's just north of Moab. If you've ever driven into Moab from I-70 into Moab and off to the right, there's that big old area on the Potash Road that's fenced off with that fence. That used to be a uranium mine, and that's where this came from. But then it turns out that as they were digging up uranium down there in the 1940s to fuel the war effort, they didn't do a very good job of cleaning up. And now that's a Superfund site because it's an absolute mess. But guys, this is actually what uranium looks like when we dig it up. You can't make a bomb out of this because it's impure, but you can get the uranium out of it that you could use to make a bomb. Now guys, the question is, what is interesting about uranium? And the answer is this. Guys, uranium is the heaviest element in the universe. Element 92 is the heaviest element in the universe. But now you're going, wait a minute. The numbers keep going up. But guys, look really close. As the numbers go up, what happens to the abbreviations of the elements? They turn from black to what? They turn from black to outline. And guys, if you go look at the key, what does that mean? Synthetically made. Guys, this is weird, but this is really interesting. Guys, every element in the universe heavier than element 92 only exists in research labs because man made them. 92 is it. Whether you believe in creation or evolution, guys, element 92 is as far as our universe got, and all the rest of these elements only exist because we make them in atom smashers. Guys, 92 is the heaviest element in the universe. Pretty crazy. So, we're making them all the time. Actually, in the next unit, we're going to watch a video about how they made element 114. It's fascinating chemistry, but it turns out the video's 5 years old now, and the whole video is an interview with a guy in California at Cal State Berkeley that's actually trying to make element 114. And in the video, they show you a picture of his research team, which is partially Russian. He's actually teamed up with the Russian team to come up with element 114. It turns out that a couple years ago, the team split, and the Russian team actually beat the American team to element 114, so they got to name it. So it's actually called fluorovium. Apparently there's a really cool Russian scientist named Florov or something like that. But we're making new elements all the time. Yeah, not a yearly basis, but close. We're making new elements a lot. So guys, again, but let's go to the top of the periodic table and talk about some lighter stuff. So guys, we got hydrogen, element number 1. Do you guys know what it means to be element number 1? It is the lightest, but what does the 1 mean? Do any of you know? 1 proton in the nucleus. So guys, what about element number 2? Helium, 2 protons, and it just keeps going. But guys, here's the thing that's really weird about this. Look at element 8, let's find element 82, lead. What does the 82 mean? 82 protons in the nucleus. But guys, what if we could strip 2 protons out of lead? What do you get? Nope, 2 protons out of lead. Actually, let's go 3 protons out of lead. Even better, what do you get? Gold. And guys, we can do that. We can take lead and strip the protons out of it and turn it into gold. It's actually not hard to do. It's cheaper to dig it up, but guys, we can do it without a problem. So what are these elements? How are they different? And the answer is simply the number of protons. So with that said, guys, look at element 11. What is element number 11? Sodium. So what do y'all know about sodium? Anything? It's in table salt. Anything else? Good for you, Brevin. Yeah, and actually it's interesting. Guys, this is actually what sodium looks. How did you know that? We? Oh, hold on. You're telling me you remember something from a sub? Oh, no. I know. Yeah, no, for sure. So guys, for those of you that are typical and don't remember anything from sub days, guys, sodium is actually kind of terrifying. I used to have a huge jar of it. And when we moved into the New Orem High School, they took it away from me. But they left the uranium, yeah. And actually, well, it got even worse when they found out I had mercury. They were going to shut down the school. But they weren't thermometers, it was a barometer. Yeah. Well, no, how do you know this stuff? Yeah. It was actually not quite that. So this freaked out, it was a woman, but it doesn't matter. This woman from the fire department came in and just had to come apart. And like she was going to shut down the school because Miss Shaw had curtains in her windows. And apparently that's a fire hazard. But when she found out that I had a mercury barometer, she went sideways. Like she ran downstairs and told Mr. Browning at the time that we had to shut down the school. And we're like, all right, just relax, big hug, let's talk about this. And so they actually did send in a hazmat team the next week to get my barometer. This guy shows up in khaki pants and a jean jacket. That was his hazmat outfit. And he goes, I'm here to pick up your barometer. I'm recording, I probably shouldn't say this. All right, we'll put it on YouTube. So he comes in and he goes, I'm here to pick up your barometer. I said, shouldn't you be like in a Tyvek suit or something? He's like, nah, it's no big deal. I'm like, wait, they were gonna shut down this, we're fine. So he goes in and he grabs my barometer and walks, he was almost skipping with it as he was walking out. But then as he was leaving, he says, do you have any other mercury? And then I was stuck, because I do. And I was like, all right, I'll just tell him. I said, yeah, I actually do. I've got a bottle of it. I use it to show it to students. And he goes, do you want to keep it? It's like, yeah, kind of. That's fine. All right, we'll see. And he didn't even take it all. So, yeah, thankfully, the woman from the fire department hasn't been back. Yeah.
Wait, what's wrong with the barometer? Like, that's
No, so the problem is the mercury, that a good scientific barometer is actually, it's like a thermometer, but it's got a beaker of mercury about this big at the bottom of it with a tube stuck in it that makes it look like a thermometer. But the problem is for it to work, the mercury has to be exposed to the air because it measures air pressure. That's what a barometer does. And the problem is that mercury is a liquid, and just like any other liquid, it evaporates. And so there's always mercury vapor up in the air from an open sample of mercury. Not enough that it can hurt you, but they're being super careful, and this woman was nuts. So yeah, it was crazy. So all right, so guys, sodium then. I also had a big old thing of sodium, and they took it from me. And I want to show you why. So guys, let me introduce you to sodium. So say hello to sodium. Yeah, right? Okay, so guys, this is actually what sodium looks like in its elemental form. So, physical and chemical properties. Ready? What is a physical property? Well, something that we can observe without making something new. So guys, what are the physical properties of sodium? Well, it's silver, and it's very soft. You can actually cut it with a butter knife. And guys, it's shiny. And it's actually fairly dense. It does, in fact, well, what is the density? You have it. What is it? Oh, slightly less dense than water. So what's it going to do in water? It's going to float. Well, yeah, but first it floats. So guys, these are all physical properties of sodium. I want to show you a chemical property of sodium. So when you put sodium and water don't get along very well. And what happens is the sodium actually rips the water apart violently. It gives off a lot of energy. But when water rips apart, it gives off hydrogen and oxygen gases, H2O, which are very flammable. And eventually it blows up.
Sodium metal in.
You can see it float.
Whoa.
Then the hydrogen and oxygen gases ignite.
So that's fire on top of water there. Little orange flame there. It's a ball here, you'll notice. It's a round shape there. And that's because it has melted. And so that's actually molten metal there rolling around the surface. And notice it's all gone there when it's all...
And if he had had enough, it would have actually blown up. But the thing that's interesting, guys, and you'll learn more about this later, as you go down this group, they get more reactive. So when you finally get down to cesium, it's game over. Like the whole beaker explodes. It's a mess. But now we know another property of sodium. Sodium reacts violently with water. Is that a physical or a chemical property? Chemical. Now, here's the thing, Terrence, and I see you, but hang on. So, guys, why then did they take the sodium from me if I'm smart enough to not huck it in water? And guys, the answer is this. If you set out a piece of sodium and just let it sit, there's many times enough humidity in the air that it will just spontaneously burst into flames. So, how did I store the sodium knowing that that was the case? You actually do. You store it in mineral oil. And you'll see a picture of that in a minute. But the problem is if you store it in mineral oil and if the jar should crack, then the mineral oil leaks out and then the sodium bursts into flames and we don't have a school to come back to. So they took it from me and I'm very disappointed. Go ahead. No, not anymore.
We should watch the video of the guy who throws like a giant brick of it into a lake.
So, okay. If we have time. You guys get the idea, right? All right. So guys, let me introduce you to another element. Go look at number 17. Chlorine. What does it mean that it's element 17? 17 protons in the nucleus. Now guys, I'm not even going to ask because my suspicion is you don't know. Although there is one thing you can pick up about chlorine given the fact that Cl is red. Chlorine is a gas. It actually looks like this. Guys, and that's interesting. Guys, chlorine is a clear yellow gas. Clear means you can see through it. Yellow is obviously its color, and it is a gas at room temperature. Are those physical or chemical properties? Physical. So let's talk chemical properties. And guys, we're going to talk about this, but please do not Google it. Promise me you won't. So guys, chlorine is crazy stuff. Chlorine is a ridiculously and disgustingly toxic gas. Now guys, if you don't know the story behind this, some would say that chlorine is not yellow. Chlorine is actually mustard colored. And guys, if you've taken history, and you have, guys, you probably know that during World War I, we were stuck. That war during World War I doesn't look like it does now, where you've got these guys with M14s, close quarter combat, kicking down doors and taking people out. It's a whole different game. In World War I, they would say, hey, this is going to be the battlefield, and everybody would run out and they'd dig holes. And then everybody would hide in the holes. And you've probably heard the old folklore story of Christmas, and the Germans and the Americans got up and played soccer and sang carols and then went, you guys know that? Is it real? Yeah. Is there? Okay. Okay, I always thought it was urban legend. But guys, we were stuck. People were dying in their trenches, not from being shot, but because they were getting sick, sitting in the cold and the wet for weeks at a time. So we had to figure out a way to kill people when you couldn't see them because they were down in holes. So we figured the way to do this would actually be to smoke them out. And so guys, we created these bombs that we then dropped. And remember, this is the US. We think we have this moral high ground about, chemical weapons. We thought of them first. And we would drop these bombs on enemy troops, and these bombs would explode and release this yellow gas, which is more dense than air, and it spreads out across the battlefield, and it settles into the trenches. And these men from other countries end up breathing this gas, and reports are it's one of the most horrible ways to die. But guys, the thing you got to understand is that gas is actually chlorine gas. That's why they called it mustard gas, is because it looked like mustard, but they were just bombs that created chlorine gas. So we now know the physical and chemical properties of both sodium and chlorine. But guys, here's the thing that gets a little nutty about this. So, table salt. You guys probably, some of you know it by its chemical name. Sodium chloride. Guys, the thing you got to understand is that in table salt, you are actually holding atoms of sodium, this shiny gray explosive metal, and a yellow deadly gas. Guys, the same atoms that are represented on the screen, you eat on a daily basis. This is just sodium and chlorine in table salt. So guys, the question is, how can that be? Because this is not a yellow deadly gas. This is not a shiny explosive metal. So what on earth is going on if that contains sodium and chlorine atoms? And guys, the answer is something magic happened. And the magic all has to do with the word compound. So guys, go down here to the bottom here, and let's talk about compounds. Definition first. Can you see that okay? Are we still doing okay? So guys, definition first. A compound is simply two or more atoms bonded together. And guys, the critical word here is bonded. Because guys, what happens is as these atoms bond together, they become something radically different than they were before. It's kind of a beautiful picture of marriage, but we can talk about that later. So, guys, the idea is that when two things bond together to form what we now call a compound, they surrender the identities that they had previously, and they take on the identities of a brand new substance when they bond together. And we call that substance a compound. So, guys, watch. This is actually
This is one of my favorite.
This guy makes me happy. He's like the uncle I never had. So,
Experiments. Supposing you want some fresh salt, none of that stale old store-bought stuff. You want the fresh stuff. You got to make it yourself. Well, how are you going to do that? Salt?
Okay, so here we go. Moving from right to left. In this canister, we have chlorine gas stored in a canister, just like helium to fill a balloon, but it's chlorine. What's that? popcorn. Not critical to the experiment, but fun nonetheless. So here we go.
Is sodium chloride. Sodium is a metal that explodes on contact with water, and chlorine is a deadly poison gas. They actually used it in World War I as a poison gas.
But you knew that.
But if you...
All right, so let me explain to you what we've got. In this crucible, it's a big crucible, in there is sodium metal. Then guys, if you can see this, here's our chlorine cylinder, and there's a tube, like a rubber tube that flows over here. Then it connects to a metal tube, you'll see why in a minute, which then dumps chlorine on top of the sodium. And he's gonna light it.
Take a bowl full of molten sodium and you blow pure chlorine gas into it.
All right, so now what we've got is sodium burning in the presence of chlorine. And as sodium burns in the presence of chlorine, the sodium and the chlorine bonds together. What does it make? Table salt. So guys, if that's the case, what is the smoke? It's table salt. The smoke from this fire is actually pure table salt. It seems like a great opportunity to salt your popcorn, which is up here in the fishing net, and that turns out to be a bad idea.
You got a fire, and the smoke coming off of that is pure salt. So we hung some popcorn over it, salt the popcorn with nice fresh salt. And it worked great. We got some good shots that we used in the magazine. Then turns out the net started melting, and it actually dropped the popcorn into the molten sodium. Sodium exploded, and we got popcorn and sodium flying everywhere. That's really not such a bad thing. It tells you that science doesn't always go the way it's supposed to. It tells you why it's important to wear a face shield and have all the right safety equipment. And it made some really good shots that we could use also. This is one of my...
Oh, huh? All right. I know. And I had nothing to do with it. But guys, the trick then becomes this. Think through this with me, because this is an important, this is language lessons. So guys, we're sold on this idea that elements are unique. Their protons tell us what element it is, sodium and chlorine. But then guys, this is the important bit. When elements come together to form compounds, they make new things that aren't like the things that make them up. Like sodium and chlorine making table salt. Guys, if you understand that, then maybe this definition for substance, we're going to move up. Guys, maybe this definition for substance makes sense. Do you find this surprising? That a substance is something that has unique physical and chemical properties. Sodium, unique. Chlorine, unique. But when you bring them together and make table salt, also unique. But now it's a compound. Does that sit okay, given what you understand? We good? Okay. We good? So guys, now what we're going to do is this. We are now going to move to the right. Guys, the only stuff that's unique is this stuff. Now we're going to talk about things that aren't unique, and things that are not unique. Do this with me. Guys, things that are not unique we call mixtures. All right. Here comes some earth-shattering chemistry. You ready? Water. But is it really water? Well, no, because there's stuff dissolved in it, right? Okay. Water is unique. There's nothing like it on the earth. Water is unique. Table salt, also unique. Nothing like it on the earth. Put salt in water, get your favorite chemistry pencil, and stir. And here's the question. Well, because it's the first one I grabbed, making it my favorite. Salt water. Is it unique? What does it look like? Water. What's it taste like? Not unique. And guys, because it's unique, we've created a new kind of matter that is not unique. This new kind of matter that we've created is a mixture, and guys, we call that mixture a solution. Notice, guys, that it is not unique. Now, when we talk solutions, there's two terms that you solvent. Again, am I okay? Should I bring it up? Jaden, what do you think, buddy? Can you see it? Yes. Yeah? Because now I feel like, well, all right, I'm going to zoom in anyway. So guys, if you ever watch a screencast and it looks like the screen blows up in the middle of the video, it's into YouTube stuff. So don't quit, just be patient. And when I zoom back out, it gets better. So guys, when we talk about a solution, we have something called a solute and we have something called a solvent. In the case of water, the solute is the salt. It's the thing being dissolved. And then the solvent is the thing doing the dissolving. It's the water. You guys okay? Because now we've got an even bigger question. Literally, we're going to climb up the ladder one more time. Are you guys good? Caught up with me? All right. So guys, the question then becomes this. Let me grab one more beaker. This is a hard question. I've never asked this question before to a class. It could be a bad question, but if anybody's got a shot at it, it would be you guys. Okay, so here we go. So this is water. This is salt. This is, well, salt water. This is salt. And then imagine sodium and chlorine as well. Ooh, let's do this. If I only had sodium and chlorine, that would be awesome. Okay, so here's the idea. We have sodium and chlorine, which are what? Elements, right? Then we have salt, which is a compound, and we have water, which is a compound, hydrogen and oxygen bonded together. And then, guys, over here we have salt water. So, ooh, I should do it this way. So now we've got elements, we've got compounds, and we've got a solution. So we've got elements, sodium and chlorine, we've got compounds, we've got solutions. Guys, here's an interesting question. I have no idea if you guys are going to be able to come up with this. Again, I've never tried this, but let's see how you do. What do they all have in common? Go ahead. But let's talk about that. And I'm not arguing with you, I'm just thinking with you. But sodium and chlorine aren't. That stick of sodium with the butter knife going through it and that thing of chlorine gas, there's nothing mixed together. It's just sodium and it's just chlorine. That's true, but everything does. Yeah. And guys, again, you feel like I'm just I've never asked, and maybe there's a better way to ask the question. No, because we got is it a bad question? I know what I'm trying to get to. I'm just not doing a good job of it. Yes, and actually that's true of everything, right? All right, I give up. It's not going to work. I'll never ask this question. Maybe that's why in 27 years I've never asked this question. But guys, let me lead you to it here and then lead you to what it means conceptually. So guys, looking at our triangle, all of these things, elements, compounds, and solutions, are all under this bigger heading that says homogeneous material. Do you see that? But that's not where I was trying to get you. What I was trying to get you to was, what does homogeneous material mean? And I failed miserably. So I'm going to take this from another angle. You ready? So guys, join me here. And you may even want to do this. Guys, we're going to talk about what homo and heterogeneous means. And guys, amazingly, we're almost done for the day. So guys, it goes like this. Let's just have an adult conversation. It's going to be weird, but here we go. Go ahead.
We're trying to get at if they're all compatible.
Are they all?
I don't know.
I know homo has something to do with humans, like it's part of, like, they're in us. Is that what you're trying to get at?
No. Okay, guys, I clearly did a lot of damage. You're closer, Jeff, but so guys, when we think of homo and hetero, let's just say it. When we think of homo and hetero, and hear me out, when we think of homo and hetero, we think of homosexual and heterosexual, right? Okay, so if you are a homosexual, you are attracted to people of the same gender. And if you're heterosexual, you're attracted to people of the other gender. Now, here's the question. If you I'm just going to say. So if you are homosexual, and if you go to a gathering of like-minded people, who will you find yourself among in that gathering? People just like you. So if you are a gay man and if you go to a gay rally, everybody that's there will be a man, right? And if you are a woman and if you are a gay woman, you will go to a rally and everybody that's there will be a gay woman, right? It's all women. Now, what if you're heterosexual and you go to a heterosexual gathering? Lots of different stuff mixed up, guys and girls. Guys, that's, so join me here. That's then the point. Guys, if we are homo, the same the whole way through genus, guys, what that means is that everything in that thing is the same stuff the whole way through. That, Cameron, is where I was trying to get you. Not even close. So, but guys, let me ask you, how could I, okay, so join me back at my little thingy here and help me fix this. You guys ready? Here's the idea. Imagine that we had that cylinder of sodium. Guys, that's sodium the whole way through. Imagine that we had that flask of chlorine. It's chlorine the whole way through. Imagine that we've got a thing full of salt. This is salt the whole way through. Imagine that we've got a thing of water. This is water the whole way through. Imagine if we've got salt water. This is salt water the whole way through. So they're all the same thing, not the same thing this way, but when you get in there, it's the same stuff that, like if you've ever swum in the ocean, it's not like water, water, salt, salt, water, salt, water. It's salt water, right? They're the same the whole way through. So here's the question, guys. Reset the clock. What would have been a better question? Given what you knew about sodium and chlorine and salt and water and salt water, what would have been a better question that could have got you to same the whole way through? Go ahead. But that's what I asked. See, you should be a teacher because you.
That one and be like, what's the same about this? Like the same about just that one thing?
Oh, same atoms, same molecules. Go ahead. Yeah. No, homo and hetero would be a physical property. Yeah, yeah.
Or like maybe start with like, 'cause I got this super wrong. Start with like defining
Homogeneous.
hetero.
Yeah.
Then being like, okay, hey, what about this is hetero and what about this is homo?
Okay. And the thing that's interesting, Terrison, is that's actually the way we used to teach this. Instead of teaching it from the bottom up, we used to teach it from the top down. So making those connections in the other direction's a little trickier. Are we good, though, on the idea of homogeneous? All right. So now, guys, all we've got this, I think, quite well. Now let's just go over here and let's talk about hetero momentarily. And then, guys, we're going to be all good to go. So, guys, when we then move to heterogeneous, again, if you're in a heterosexual gathering, what do you see?
You're gonna get arrested.
What do you see? Yeah, guys and girls. Guys, right here. Guys, what you see is many types of people. Many types of matter. Now, guys, along the way, there are some terms that you need to know, and I'd like to share those with you. And this is the end of your notes, almost. So, guys, when we think about heterogeneous mixtures, there are some terms. The first one is the definition. So, guys, heterogeneous material contains more than one phase. But, guys, to understand that, you need to know what a phase is, so allow me to define it. Guys, a phase is a physically separate component of a mixture. And then, guys, the last term relative to this that you need to know is the term interface. And an interface is the plane of contact between distinct phases. So guys, let me introduce you to some heterogeneous stuff when you're ready. So is heterogeneous the same the whole way through? No. It's hetero. It's different stuff mixed together. So, not dirt. This is a little nostalgic. Guys, this is what's left of the old Orem High School. Yeah, so, yeah.
Hey, Mr.
Who?
Chris has bricks of it.
It was this was a mess. Like, literally and figuratively. Guys, many of you were around when we moved into the new building and ripped down the old. And it was actually really kind of scary. It felt like a riot, like in a big city. And because people were like ripping lockers off the wall, stealing bricks hammers. People were like chipping Orem High School apart to take it home. And some of this stuff the district actually wanted. Like the district brought work crews to the school to systematically collect the stuff, like the lockers that they wanted to reuse in other schools. And these workmen would carry the lockers out to their flatbed trucks, and literally neighbors were stealing the stuff off the trucks. It was crazy. So I went a little less risky, and this is actually some of the gravel from when they demolished the smokestack. I don't know if any of you saw that. There was the old heating smoke, and this is what Orem High School used to be. But it's heterogeneous, because this is a chunk of concrete, and this is actually a chunk of granite, and they used to be glass and all sorts of other stuff in here, but I got rid of it. But guys, clearly this is heterogeneous. It's a bunch of stuff mixed together, right? Let me give you another example, though. This one's a little trickier. Guys, this is also heterogeneous. Let me explain to you what you're seeing. Down here on the bottom, this is actually just water with food coloring in it. And then up top is cooking oil. I made this last year, and over the summer it went rancid. It's kind of gross. Actually, there's mold on top. But, okay, so guys, the reason that I show you this is not only can you see that this is heterogeneous, but guys, what do we call each of these layers given the terms on the board? They're phases. This is a phase, and this is a phase, and where they come into contact, we call that an interface. Right. So guys, question number one, how many phases are present inside this flask? I'd give you 4. The water phase, the oil phase, the air phase, the mold phase, the air phase, and the stopper phase. So there's at least 4. But guys, are you convinced that this is heterogeneous? What about now? Yellow and blue makes green. I know. So, is it still heterogeneous? Well, it is mixed together, but so guys, what about this? What's going to happen if I stop shaking? It's going to separate. But guys, what about this? Salt water. If I stop shaking salt water, will it separate? Never, unless we boil the water away. So guys, this then is the difference. Oh, and wow, it's separating quickly. Yeah, it's the mold. So guys, we've got this which is separating rapidly, and this that will never separate. So this is hetero and this is homogeneous. But if that's the case, it's still heterogeneous. So the way I like to test it is this, a little mental game. If you could shrink yourself really small and swim through this, besides being really nasty, what would that experience be like? Yeah, water, oil, water, oil. It's not water oil, but that is salt water. Right? So this is heterogeneous, and that's homo. Are we good? One last thing. Guys, allow your eye to scan to the top, and we now need to throw the broad umbrella. What do all of these things, hetero or homo, they're all matter. And guys, matter is anything that exists and therefore has mass. So, guys, let me explain to you then what you're going to do on Wednesday. So on Wednesday, you're going to grade this homework. And then, guys, what we're going to do is you're actually going to go over into lab. And you are going to be given a bunch of substances. What could those be? Elements or compounds, right? You're going to be given a bunch of substances. And you are going to be doing a bunch of things to those substances. And you are going to figure out if you're looking at physical or chemical properties. And then you're going to be identifying whether the things that you're playing with are elements, compounds, solutions, or heterogeneous mixtures. Now, guys, in order to prepare you for that, we put together about like 12 minutes. Is it 10 till we get out? Is it 5 till? No, it's 5. Oh my gosh, guys, you'll get this done. So guys, front and back, do it now, get it done before you forget all of this stuff. And then we'll grade this on Wednesday and we will get you to lab on Wednesday. Those are the same. So existing by definition means has to have mass.
So it's not anything which exists has mass.
That is true. So anything that exists has, I wrote it as 2, but really what you said is more correct. As a statement, anything that exists does have mass. Well, but we don't have to talk about it. Except for electrons. Well, no, they have mass. Except for photons. Well, fire has mass because fire is just excited gases.
So, if we brought sodium to the school, would we get, like, expelled?
No, you would get expelled.
My experience has been, we don't like to hold kids responsible for their poor choices. So no, it'd probably be me that goes in jail.
If I brought like a 5-gallon bucket full of match heads and I didn't even bring it to your class, but it's like put it in the parking lot.
So,
No, I think that's a great idea. Maybe I should stop recording.